World Maths Day. We're running a competition today, and the answers to the competition will all be found within this video. So pay careful attention. I don't know if you've ever been to the Great Pyramids at Giza. They were built around about 4,500 years ago, which is a very long time. And did you know that mathematicians have found out a formula to work out the volume of a pyramid? And there it is on my screen. It's 1/3 of the width and the length of the base times the height. And you might think, well, what's the point of that? When am I ever going to use that, and why do we teach it in school? Well, actually, imagine we had a block of stone that was the length of your ruler. So that's 30 centimeters, or in old units, a foot. So imagine 30 by 30 by 30. How many of those would I fit inside the Great Pyramid? Well, it's been measured, and it's 755 along and 755 wide and 481 feet tall. And so that would be 91,394,008 of those blocks. So imagine if your job was to move every one of those blocks in position 91 million times. That might take you quite a long time. As a teacher in mathematics, I quite often have a conversation with my students where they say, what's the point of learning this? Maybe you feel a little bit like Calvin here trying to do maths with his dad. And the purpose of this assembly today is to show you how relevant mathematics is in the world of employment. I wonder what you hope to do after you leave school. Well, here are some examples. So a lot of it has to do with money, which is important to every one of us. So maybe you want to manage your household income and outgoings. What about getting a credit card? What about taking out a loan or having some savings? The work we do introducing you to interest rates and percentages is really important. Many people will get themselves a mortgage at some point when they try to buy a house, and you want to make sure you get a good deal, or you could find yourself facing repayments that actually you cannot sustain. Maybe you know Olaf here from the movie Frozen. Well, a lot of people have jobs looking at animation, and when the people at Disney are looking to animate people like Olaf, they use mathematics to do that. They draw him once, and then say, if they want to make him move across the screen, they use the maths of transformations. So here we have what we call a translation. What if I wanted Olaf to say, fall over? Well, look, that's just a rotation. What if I wanted him to go backwards or go forwards? Again, those are enlargements. We take the same shape and we enlarge them. Or what if he's standing on a lake and you see a little bit of the reflection underneath? Well, surprise, surprise, that's the mathematics of reflection. And indeed, there are other transformations we do later on with mathematics that are very helpful as well in animations. And who knows, you may find yourself doing work like that in the future, but you were taught it here. Some of you may go into work with medicine, and part of that has to do with drugs. Here's a picture from a nursing textbook. The problem with giving people drugs is you have to work out the dose, and that can depend on a number of factors, including the weight of the child or the adult patient. And you have to make sure that you get it right, because not enough won't help them, and too much might actually harm them. Indeed, nurses have these cards to help them with conversions, and you can see there converting from grams to milligrams, from litres to milliliters, from all sorts of different units, and the things again we introduce in school because they are useful in our future lives. Have you ever thrown a ball and noticed the shape that it travels in? That curve is called a parabola, and actually that's a really, really useful curve. Mathematically, we can model that, and we can say if I throw it at a certain speed, it will travel in a certain way, and at any one point I can tell where it ought to be. And you think, well, why is that relevant? Well, for example, if you were going to be in the future sending a satellite out into space, you need to be able to know where it is and be able to track that. The parabola is used also in telecommunications, and here we have a satellite dish. Parabolas are often found architecturally because they're really helpful for weight bearing. If you were into architecture or civil engineering, building bridges or things like that, understanding some of that is so useful. And who knows, perhaps one day you might even get a job designing roller coasters. But you want to make sure before you build it and before you test it that it is safe as well as fun. And you would use mathematics to ensure that that was indeed the case. I don't know if you know this photograph. That's from Staverton Airport, which is our local airport. And inside Staverton they have a little room where the air traffic control officers work, and they are making sure that all of the aircraft flying are able to take off and fly and land safely without crashing into one another. Now, Staverton doesn't have many aircraft, but this is a picture here that I took a little while ago of all of the aircraft currently in the air above our part of England. And look how many aircraft there are and how many different directions they are travelling in. And making sure that no one crashes into one another or even comes too close is a really important job. Indeed, here is just one of those aircraft. This is a Lufthansa. You can see the aircraft is heading more or less west, and the computer will track and say this aircraft is going at a certain speed, a certain altitude, and is going in a certain direction. We don't just say west, we use the language of bearings to make sure that we know where that is going. So distance, speed, time, and even looking at X and Y and Z for a vertical coordinates, so we know what direction the aircraft are going, and we can track that actually there's no danger of a collision. All of that comes down to mathematics. Maybe you'll get a job working in Asda. Maybe in 10 years' time you'll be a manager of a large department. And if you're the manager, you need to make sure that Asda is running smoothly. Because if I go in, I'm looking to buy a couple of tins of baked beans and the shelves are empty, and I say, well, I want baked beans, and they might say, well, sorry, nothing till next week, I might stop shopping at Asda and go and start shopping at Tesco's. So where do those beans come from? How does the manager make sure that the shelves are stocked up? Well, they come from a great big warehouse, and they have loads and loads and loads and loads of boxes of stuff that are sold all the way through the Asda chain. And how do they get there? Well, a manager will order a delivery. Give me 5 boxes of beans, give me 2 boxes of potatoes, etc. But you need to make sure that when that lorry goes out, that you have what you need for this coming week, and you're not ordering stuff you're not going to need, and you also want to make sure that the lorry isn't like half empty. So how do you do that? Well, mathematics allows us to model that, and we call this network analysis, and it's a complicated way of making sure that actually what you need is there when you need it. Back in 2017, which isn't a very long time ago, Professor Martin Boom gave this quotation. He said, 80% of jobs that will exist in 2025 don't exist today. Now, 3 years on, that's probably still just as true. I don't know what job you'll be doing in 10 years' time, but chances are it is going to be something new. And chances are you're going to use a lot more mathematics in it than you ever expected. So, when you go up those flights of stairs to do maths this week and next month, actually it is relevant because we are looking to prepare you for your future. Well, thank you for watching this video. I hope you find it interesting. Your form tutor will now hand out the competition entries, and let's see how many of those you're able to answer correctly, and there will be prizes. Thank you.